So I'm doing today's Leetcode 3306. It's count of substrings containing every vowel and k consonants. So it's a pretty simple question. You need to return the number of substrings that contain all the vowels, all 5 vowels, and it and that substring contains exactly k consonants inside it. So my approach is to use sliding window, but 2 of them. So I have the shorter side of the sliding window, like the lower bound of the length of the window, which I call short, and I put S as just abbreviation, and the upper bound of the length of the sliding window is L, which stands for long. So I have 2 hash set, and I have the integer out, which I can't keep track here, and then this one is the, well, S basically means for short, and con and vowel basically means consonants and vowels. So it's basically counting how much consonants and vowels inside of those windows. So it's like a for loop. I iterate each of the endpoints, and yeah, so basically this one, if it's a vowel, I just load it up into the hash map, because for vowels, right, you need to contain all of them exactly once. So I need to know how many unique vowels are there in the thing, whereas consonants, I just count them directly. So if the hash set already contains that vowel, and then I just increment its frequency. Otherwise, I put it there and I increment the count of unique vowels in there. So these two are actually 2 different things. It's not just the difference between vowels and consonants, but this one is it counts how many unique vowels, whereas this one just counts the amount of consonants in the window. And I do the exact same thing for the upper bound sliding window. So that's why you see these ones and these ones, they look exactly the same, except that I change S with L, like MPL from MPS, and LCon from SCon, LVowel from SVowel. Yeah, so that's basically the loading part, like the right side. That's when the things are being loaded into the sliding window. And if the amount of vowels is less than 5, which probably happens in the beginning, and the amount of consonants, I probably don't need this. Yeah, as cons less than 5, I don't need this loop, this checking. So this other side is where we do the contracting side, the left side. So this is for the lower bound. Of course, I always do a check if the vowel is 5. Yeah, so we can actually move forward. And here, if the amount of consonant is greater than or equal to k, we don't want that. We want this lower bound to be the first one that is less than k. So yeah, just similar technique. If vowel, and then do an operation to decrement. If it's 0, if the frequency of that vowel is 0, then remove the vowel too, the amount of vowel. Same thing for the upper bound. And finally, this is just to check if the conditions are valid, because sometimes you might have more than k but more than k consonants in the long bound, but it is stopped by the vowels. Yeah, so let's give it a try. All right, let me make some custom test case where it's just a bunch of random run thing. Yep, I'm confident enough with this. Wait, let me just check one more time the yeah, I can keep waiting, I guess. Wrong answer. Oh, I did not consider casework. Oh, it's an overflow. Always make sure to check the output type, okay? It's an overflow. All right. Signed integer overflow. What a wonderful thing. See? Double sliding window. You got to understand this technique. See you tomorrow.